Hey, it's Jesse. I'm here at the Wolfram Tech Conference. For those who are just tuning in, I'm just here talking with developers and other interesting people using Wolfram technology in really cool ways. I'm here with Tuseeta right now. Can you tell us a little bit about sort of what you do at Wolfram and also what you are doing here at the conference this year?
So, uh, just a week back, I moved to the advanced research group, so in the machine learning team. So, I work as a research scientist trying to implement and get import models for the Wolfram Neural Network repository and also to build applications for various high level functions in the Wolfram language. So, that's what I do.
Yeah.
And in the conference, I already gave a talk which was just about what we have added in the neural network repository and how to use that to make real world applications or how you customize them to make applications of your choice. And then I would be giving another talk later, which is kind of one of my favorite projects, where I talk about like it's more for the social, like how you can use Wolfram neural networks for cancer diagnosis. So yeah, that's what I have been, what I am doing in the conference,
Cool.
other than hanging out with people.
Oh yeah, well that's like the best part, right?
Exactly.
So just for our audience, like what is the neural net repository? We've talked with Matteo earlier, and he told us sort of the new things in the framework, but we didn't talk too much about the repository itself. So what is it, and sort of how can you use it?
Okay, so the Wolfram Neural Net, the repository, let's just shorten it to repository for now. So the neural net repository it was launched a few months back, and it has almost around 80 models or so, which you can use for various applications. So it goes from image classification, object detection, then you have semantic segmentation. I guess I could further explain each of those terms because for somebody who's not familiar with all of these tasks, it's sort of Greek.
Yeah.
So otherwise, there are various image processing neural networks. So essentially, it's a library of pre-trained models. So one feature or one thing which I should mention is that all of those models there are not trained. Some of them are trained at Wolfram Research, but many of them we have taken models that have been implemented by like well-renowned researchers, and we got them. The weights have been verified and tested, so we go through a lot of steps, processes before we actually publish a model in the repository.
Nice. So they're like just highly curated, usable, sort of
Yes.
pre-trained. Okay.
And then, so for example, so there was a blog post with Sebastian and Matteo and Megan and Tali wrote about the repository. So if you refer to it, you see like the ultimate the what should I say, the result which you get from the repository by getting for asking the net to do something for you. It's in most of the times it's in the entity, so it's like a rich computable
Okay.
data
Yeah,
format
yeah.
which you can just go and query and use for your own application. So it's easy to use. Very well trained neural nets which you can just use for your own applications.
Oh,
So,
that's awesome.
yes.
So, speaking of applications, what are some of the like coolest applications or the funnest applications that you've seen of or have done of Wolfram neural networks?
Okay, so for me, I am more application driven rather than engineering driven. So for first of the few were most of the ones which I like for some social had some social
We're doing some
implications,
stuff.
and then so let's start talking about like one of them. Okay, so
Yeah,
let's.
sorry, I just plugged in this HDMI cord, so hopefully it's not just messing with your screen too much.
Okay, yeah, that's fine. So let's go to the first one. So here, so more of these will come in the talk later, but I'm just showing a sneak peek of the thing
Yeah.
here. So so this one was for cancer cell detection. This so when we started building this application for a client, so at that point in time I was working for the services team, that's a consulting team within the company. So at that point we didn't have any segmentation network in the repository, so we had to build this from scratch. So my point of showing this was how much time it takes to build a network from scratch, train it, see, check accuracy. That's more time consuming than
Right.
rather take a network from the repository,
Yeah, just grab
do
and go,
surgery,
sort of.
just
Yeah.
cut up the head and the tail off. That's how we say it's network surgery, and then put in your own layers and make applications. So, but this one was trained from scratch. So this one is SegNet, so semantic segmentation. It was a model that was published in 2015. So these are essentially the layers that I had to put in together. So each of the model consists of an encoder section. So this is inspired from VGG 16 or VGG 19, just has some batch normalization added to it. Okay. So yeah, these are all layers that you get in the neural network framework in the Wolfram language. So this is essentially the encoder section of it, and then the decoder section, and then you put them both together, stitch them up. Uh, Again, joining layers of these to make your own application is very easy. It's just net chain, and then you just chain them up. Or if you have a graphical structure, use net graph and then put the chains to make a graphical structure of the layers.
So net chain and net graph are functions, and their arguments 1, 2, 3 are basically the layers you want to stitch up together.
You can give them as a list, or you can give them as associations.
Okay.
So associations, like associative arrays, and
Yeah,
then
yeah.
just to name the layers so that you can get them. So these are all the arguments which you put
I see.
to chain the layers together. So and for graphs you do need to give the connections. Like in any graph,
Oh, yeah.
you need to give the connections.
Makes
between the
sense.
two.
Like 1 to 2, 2 to 4.
Two to
sort
four,
of,
yeah. So this is how you would essentially train from scratch. So the first application I wanted to highlight is how you make a network from scratch and train it. So here, let's go to the results. They look more interesting.
Oh, yeah.
So this is so. In the talk, I will go in more details about what each of the applications are. But here we are just seeing some H&E stained images. So they are this colorectal images which I got. So there are from publicly available data sets. So this one shows just benign tubules. And you can see that, so the original image looked something like this. And so this is again a part of the image here. I'm just parting them, and then I'm just showing the last as all the images stitched together. But as you can see, these red outlines you see here is what the network actually detected the boundaries of the images are, and the blue ones are from the ground truth or the masks that I got from the data set. So it performed really well. So if I think it had around 94% pixel-wise accuracy, and this was a pixel-wise segmentation network which was built for this purpose. So yeah, this one was more of like I wanted this for like a broader implication of how you can use neural nets for different applications.
So this is the one that when you were in tech services you built from scratch and used for the client.
Yes. So this is so we didn't actually use it because this one's more for public.
I see. Yeah.
This is a public data set. So yeah. And here is one which is from summer school actually. So he wanted to make something for solar, to calculate solar energy, like how much solar energy you can get if you just had panels on top of rooftops of just buildings, like buildings you have in the city. So that's exactly. So we have used something similar. So this is also a semantic segmentation network. But instead of training from scratch, we are just using the repository to make this model. So you see that the lines of code have gone down tremendously.
Yeah.
So you just take the model, just getting the model is just a single line of code. Take the model, just break it up. So here we are dropping the last two layers. So and then add your own layers for your custom application, and then stitch it all together. Stitching part is same, and then training part is slightly modified than what you would have trained, but not much modification, and then you get
So
network for yourself.
does it train the whole network, or like retrain the network, or does it only train the two layers that you added?
So essentially, you really don't want to retrain the entire network. The main reason why you don't want to do that is because training all the layers requires a huge amount of data, and for most of your applications, you don't really have millions of images for getting that level of accuracy. So what you do is to freeze the first few layers, and get the weights from the pre-trained model, and let the last few layers learn. So it could be your layers and some part of the architecture. So if I had to show it here, let me try to get this. So what this application had was, we tried, let me zoom in a little bit more. So we let it learn from 6A to the end and kept the above layers fixed. And you do that using learning rate multipliers, which is again a function in the Wolfram language.
I see. Okay.
So that's essentially how you do network surgery and use transfer learning. So you are essentially transferring the learned weights from the first few layers and using it for your application. So that's how you would do it. As
So that's the repository workflow versus the Scratch workflow.
Scratch workflow.
Yeah.
Yes, the first one was a Scratch one. The main reason I wanted to show is because you have the repository. Life is more simple to make your own application.
Oh yeah, and I'm all about. I mean, especially because I'm not like a neural net expert.
Yeah.
I would want to grab something like that's like easy to use and just like ready to go and sort of minimal changes. Yeah.
And just as a fun fact, most of the students here who came to the summer school did not really have a background in neural networks or AI or machine learning. They had some experience with the Wolfram language, but they built all of it in a week. So if you happen to know more machine learning or Wolfram language, I think you can just build it in a day or two. Just train it. The GPU training time does not really matter. Like it will take a day or so, but then that's how long it would take to make your application.
That's crazy fast. That's
Yes.
a very low learning curve, I think.
So yeah, so let's go ahead and so I am just showing. So I'm just getting the pre-trained network here. So here, what I am doing is just grabbing using again Geo Image. So this is the I should say the cool thing about our framework is that you have different functions built in for different things. So I could just get a Geo Image using the Geo Image function, and if I had to do the same in some other framework, I would have had to load different libraries. Like if I'm working with the machine learning or the TensorFlow library or any neural network library, I need different other libraries to get things like this.
Also, you can pass images as valid inputs for the neural net. I don't think that's the same for other frameworks. You have to
Yes.
convert it to like their matrix
The
form.
matrix forms, yes. So we do have net encoders and decoders. Thank you for pointing me out to that. So here you see, I hope, yeah. So here you see, all I am doing is saying that I am feeding it an image, and I'm feeding it the image of this size, and this is the mean of the image. So there are many a times where you would see that accuracy increases if you subtract the mean and the variance of the image, and that's a normalization process. So you need to normalize your images. So essentially, net encoder for images are so well built that you just give, this is the mean of the image, this is the variance of the image, this is the size I'm feeding, and it will take the image and pre-process it, make it ready for the framework. So that's a very good point. Yes.
That's pretty cool.
Yes. So this is the test image. I just looked up the geographical, like the latitude and longitude of Champaign-Urbana. So that's the latitude of Champaign-Urbana. Let me go ahead get the mask.
It's very grid. It's not a perfect grid.
It's not, yeah. So again, so for neural networks, if it's okay, for neural networks, if it is over time, is it over time?
I mean, I just real quick. I think we don't have enough time to go through this.
Okay.
But just real quick, what's the funnest application that you have? Real
Oh,
quick.
okay. So yeah, so this is something which I built just for fun. I was video chatting and I'm like, yeah, these Snapchat filters are very easy to make. You just have to find the faces, and there are. Okay, I did not initialize the cells. Let me just go ahead and.
So you wrote all that just for fun.
Yep, I wrote that for fun. So let's go back to it. So here we have find facial features function. So it will find all the features in your face. So it finds essentially I saw which number corresponded to the right ear, the right and the left ears and the nose, and just put the bunny things to it. So
that's a really funny Christmas card.
yes. So I publish it for Eastern communities. So
oh my god.
Yeah, and yeah, this is how I just made it for multiple faces. But that's when I realized that you cannot do these things for mobile handheld devices because these networks are huge, and that's also some complaint that we get from customers that these are big networks. So right now, which will be coming in 12, that's another project that I was doing, is to find networks. So we have the recently published again MobileNet from TensorFlow. So we have imported them in our framework, and that would be published as parameterized net models because we have so many of them, and you can choose which version you need for what sort of application, and
including mobile.
So you can actually run them because they are smaller networks. That's what I was trying to show here. So the ResNet, which has similar accuracy to the top the best performing network, has around 60 million parameters, while this has 6 million parameters.
Okay,
And
yeah.
so it's like a factor of 10 less. And which means that these will be much smaller, at least a factor of 10 smaller, and you can use them for your mobile devices. These were trained to do that kind
So
of
Wolfram
applications.
Language will support mobile neural networks in version 12.
They will support smaller networks, and then again, the image processing team is busy taking these networks and putting them in image identify and audio identify so that you can have like a smaller network for each of these functions.
That's awesome.
So yes, we will have smaller networks.
Cool. Well, thanks for talking with me, Tuseeta. I appreciate it.
Thank you for inviting me.
Awesome. So stick around. I'll be interviewing more developers a little later on.